Alright, ready? Right. What we doing here again? What you do here? Add, right? What you do here? Minus. What you do here? And to the power of zeros. What about here? How about here? 1 over 8 to the n. And what about here? 1 on n, right? Right. So, although I give you the indices rules first, we're going to focus on surds, right? We're going to focus on surds and then we'll come back here. So, within your surds, there are a couple things I want you to remember. What is root A by root A? What is root A by root B? Right? What is root A plus root A? What is A over root A? What is root A minus root B by root A plus root B? Write them down fast. Write them down fast. And we're going straight into a few examples, right?
So we're doing pretty well.
They go on my wife. By my wife. Where?
Which one? Oh, I'm going to say we're doing.
Hold it down. Like sparks. Real hard. But I know it would be hard sometimes. I'm not reading this way.
So the key nail something again. Key nail something.
I think it too. Ready? Right, so just some quick rules to go over. If you remember in advanced, you didn't really spend much time on search, right? So we spend a little more time, but the same type of questions. It's not much harder, right? Than what you would have practiced in advanced. What is root A by root A? Root A by root A is A. Where does this rule come from? Same base, and we can add the powers. So it's a combination of here and here. That's okay? So it's like a half plus a half is 1. That's okay? So the rule technically comes from there. What about root A by root B? That'll be root AB. What is root A plus root A? 2 root A. Nice. What will happen here? A is what? A is root A by root A, right? So root A by root A over root A cancel. So you'll get root A. What about here? How are we doing this? You can do it the long way. You can multiply root A by root A. Root A by root B. Root B by A. Root B by, sorry, minus root B by that is plus B. What will happen here? Cancel. So you'll get A minus B. Right? What's the short way? The short way is what? Difference of 2 squares, right? Root A squared by root B squared. Everybody okay with that? And one last thing I wanted to remember before we jump into this. What is the conjugate of, let's say, root A plus root B? Right? Conjugate of root A plus root B is to just change the sign in the middle. That's okay? So it becomes root A minus root B. You okay with that? So conjugate simply means you can change the sign. Right? If you're not seeing here, you can try up there, right? Yeah. So conjugate means we just changing the sign. Right? Let's jump straight into a few examples. Try that now. Try this here first. Remember, you can always drop it into your calculator and check the answer, right? Right, you can always check on the calculator just to make sure you get the same value. I know I didn't show you one like this, but what will be 2 root 3 by 3 root 3? What will be 2 root 3 by 3 root 3? What you do first? Multiply the numbers first. 2 by 3 is root 3 by root 3 is. So you'll get 18. That's okay? So you multiply the 2 by the 3, then the root 3 by the root 3. I'm going to start with this now. Right? But I get you. So 5 by 3, that's 15. 5 by 2 root 3 is 15 root 3. 2 root 3 by 3, that's 6 root 3. 2 root 3 by 3 root 3, that was 18, right? Bring the numbers together, 15 plus 18, and work with the surds after, right? 15 plus 18, that's 33. 15 plus 6, that's 21 root 3. You okay with that? Easy, right? Right. Since you all find that easy, let's quickly look at rationalization, right? So how do we simplify? How do we simplify something like this? A plus root b over C minus root D, C plus root D. What do? Right? Multiply by the conjugate of the denominator, which is C minus root D, all over itself. That's okay? So how do we simplify these fractions? We do a technique called rationalization. So we multiply by C minus root D over C minus root D. How we get this? Conjugate of it. That's okay? Jordan? Right? Try that there now. Try number one there with the rationalization. Easy, right? No calculator, gotta work it out good.
Why not finish it?
Huh?
That's it.
Wait, that.
Era multiply with conjugate. Conjugate and no. By the way,
Okay, so I'm going to the original thing. Remember, it's rationalization. It's moving the third, right? By the way, the thirds belong to what set of numbers? Irrational, right? So when they say rational, they mean they want the denominator to turn into a whole number, a rational number, right? So when they say rationalization, they want it to move from being irrational to irrational. Okay? So you multiply by root 6 plus root 2 over root 6 plus root 2. So your denominator is root 6 squared minus root 2 squared. There's no need to multiply it out, right? Right, everyone? Send me a message. Yeah. Finish already with one. So root 6 by root 6 is 6. Wait, look at split. Root 6 by root 6 is 6. Root 6 by 2 is root 12. Root 2 by root 6 is root 12. Root 2 by root 2 is 4. Right? Root 6 squared, that's 6. Root 2 squared, that's 2. So I got 4. 6 plus 4 is 10. Root 12 plus root 12 is 2 root 12. This can simplify a little bit more, right? It's a 10 over 4. Sorry? Oh, here. Sorry.
Yeah.
That's it. Sorry. Thank you. Can see it, right? plus 2/4. But can I sit?
Don't give him last.
Sorry, but I might cut. But that's all. Right. How do we break up root 12, Olia? How do we break up root 12? Can we simplify root 12? 12 is what? 3/4, right? So that'll be root 3 by root 4, which is 2 root 3. Right? So I could write that here. Instead of writing root 12, I could write 2 root 3. So I'll get 2. 2 by 2 is 4/4 is 1. Right? That's the final answer. If you go to calculator, you should get that final answer. Second thing. Yeah? Anybody get lost? Adam, where you get lost?
Because if I open up bracket, it'll be 4, and then it'll be 2, 3.
No, it will be 2 by 2 is 4.
So,
No, it's just 2 by 2 alone. That's it. Then no cancel. Huh? So 2 by 2 is 4. 2 by 2 is 4. The 4 to cancel, you'll get root 3. 8 on 2. Right? Oh, by the way, that's 2008, right? Yeah, that's pure. Very easy, pure math easy, you know. Except for 1 or 2 small things, pure math really easy. Try that first. Similar thing. But remember, it's not market already. Yes. So yeah, let's get like simplified. But if you add much, if pure, they will save both of If you have a whole number, take your time, work it out. I just from halaman to it. I just read seen halaman to it. How much you all got?
I don't know. I have three. We get three. Oh, no, we have four.
It should be a whole number between 1 and 5. Should be a whole number between 1 and 5.
Okay. Fine.
You all done? Supposed to be a whole number, right?
Yeah.
I think we worked out one already. This one here is what? 2 plus root 3. Right? We didn't work out this as yet. Right? We didn't work out this as yet, right? So we multiply by root 6 minus root 2 over root 6 minus root 2. So what would I get here? I shall get 6 minus root 12 minus root 12 plus 2. Right? All over root 6 squared minus root 2 squared. So I got 2 plus root 3 here. 6 and 2 is what? 8. 8 minus 2 root 12 all over 4 again. So this simplifies the, I got 2, right? So again, I had to simplify this root 12, right? And I will get 2 minus root 3. This will cancel and I'll get 4. I'll get that 4.
That's it.
Remember, you can't just put it in the calculator, you have to show them the working, right?
Don't I see both?
Let's do our next one. That was 2008, right? Number 1 part B.
It's. Yeah, probably. I did have those.
Ready? Last one. A little bit longer. Hold on, the hard copy. But you can buy. You don't have it like this. And you use stop doing that. Stop doing it. But this is to be nice and straight, but stop doing it. What they basically have it full of people, but no, not straight like. I was sending out. Right, try this here. Should be a nice whole number again, right? Root 3 minus 1. Root 3 minus 1 over root 3 plus 1. Plus root 3 plus 1 over root 3 minus 1. Plus root 2 minus 1. Root 2 plus 1. Plus. It's not me, I just given you what I give you.
It's very rushing.
No, yeah, the next way you can do it. But yeah, it's up to you.
I think you're next.
I gonna do the next way.
I know you next.
Hello?
See me next.
Yeah, I'm alright. Are you gonna repeat right? See?
Start bringing down to it again.
Oh, no, here was not. When you
This. No, I won't go. Saya 8 minus 2.
When you hold it,
Yeah.
supposed to be a whole number, but you gotta work it out anyway. Make sure I put it in right, huh? So yes, one of the options is you do it individually. Or what else we can do?
You tell us.
What else we can do? No calculator matter. What else we can do? What you can do there? Pair them up,
Yes, sir.
right? Can we pair them up? Work out here and work out here. Huh? Well, yeah, well, there's so much marks. Five marks.
I didn't know it.
Right? Just find the LCM and work it out. Or do it one by one. It's up to you. One by one.
1 by 1.
No.
Usually 50 beginning.
I see now. Finish? Then work it out. I don't want to work out the thing now, boy. Everybody get? How much? 10. 10 is the values. I'm going to start with this now.
Please.
The last one we're doing, then we're going to end this week, right? I just want you to have a little line there. Right? So if you want to work it out, instead of doing it each one 4 times, what we could do is we could do these two together. So it will be this by this, right? So it's like finding the LCM, right? So it will be, I'll write it out in full. Root 3 plus 1 by this. Root 3 minus 1. This by this. Root 3 minus 1, root 3 minus 1, this by this. Root 3 plus 1, root 3 plus 1. Right? When you work out underneath here, this is difference of 2 squares. So you'll get 3 minus 1. Numerator here, root 3 by root 3, that's 3 minus root 3 minus root 3 plus 1. Do the same thing here. You'll get 3 plus root 3 plus root 3 plus 1. You'll recognize this will cancel. And you will get 4 and 4, 8. You'll get 8 over 2. So you'll get 4. Right? That's the first one. Next one down here. Huh? Okay with us? Next part. So you do the same thing here. Root 2 plus 1, root 2 minus 1. Everybody okay with us? So what you can do is, because these are conjugate pairs, you will end up rationalizing. If they weren't conjugate pairs, then you have to do them individually. Okay?
You never bring a customer.
Like what?
Like with individual.
Not 4. We like 2. Huh?
I guess it way. Use the notes. I don't like it. Why is it good one? Don't like it. I use on the using. I don't like it. That one you just go. So I'm using
Right, now cancel, so you got 4, 5, 6. Right, so your final answer is 10. All right, so that's all. practice on Surds, now we're going to indices, right? Very hard. Very come on. What is really come is like the long and the log. And then you have to do your reach here. Then away. So they might necessarily see a question on Surds, but you might get an answer like this. And this is sensitive. So you don't come hard.
Useless.
Alright, ready? So we're gonna take a look at the way this equation has come. Alright, let's go. Right, so exponential equations, right? Ready? Right, so we need to be able to solve different types of equations. So if I gave you 2 to the power x is 4, right? Questions like this, all we have to do is we could equate, right? We could equate powers provided that what? Provided that they are both to the same base. So 4 is really what? 2 squared. So that will be x is 2. That's okay? Yes. So if I give it something like this, 3 to the x plus 2 is equal to 9 to the x minus 1. What's the first thing you have to do? Convert them to the same base, right? So this will be 3 to the x plus 2. 9 is what? 9 is 3 squared to the x minus 1. So this is 3 to the x plus 2, 3 to the 2x minus 2. Now we could what? Now we could equate or compare. So you'll get x plus 2 is equal to 2x minus 2. Bring all the x's on one side and keep all the numbers on one side, right? So I got x to be 4. Yeah? What would happen in cases like this or there? 3x, 3 to the power of x is equal to 5. Take logs, right? So whenever you can't convert them to the same base, we take logs on both sides. But I'm not showing you this as yet, right? We take logs on both sides, right? We're gonna spend a lot more time on logs because we didn't do it. That's normally one of the hard things. And then sometimes it might look like this. What would happen if you see three terms like that? Right? Whenever you have 3 terms, what you have to do is you have to make a substitution. So I'm just giving you the general steps, right? you have to make a substitution. Right? How do you figure out the substitution to make? Earlier? How do you figure out the substitution to make? It always comes from a little second term here. So the substitution that we generally make is this. Right? Substitute 2 to the x and then solve the quadratic obtained. All right? So we're going to practice those there. Yes.
Yes.
Right? So these are the three different types of equations, right? So these where you can equate to the same power, where you have to take logs, and then where you see three terms, and you have to use quadratics to solve them. All right? Right. I won't do it as yet, but there's a new exponent that we have to learn, right? Called e to the x. Right? I'll show you in a little while. Let's just go and practice a few of these, right? Right, so let's start here. Solve. This is 2002. 2002. Solve for x. Right, so this first one here is supposed to be what, Emma? First one, in the block, naked one here. 2 to the 2x minus 3, 2 to the x plus 1 plus e. Be careful with the plus, huh? What you should do? Multiply by, right. So the first thing you should do, but by the way, 1, 2, 3 terms means that it should be a what? Quadratic, right? So the first thing that you should do before you make a substitution is just simplify this a little bit. What does plus mean again? Plus means multiplied, right? So it will be 2 to the 2x minus 3 by 2 to the x multiplied by 2 to the 1. So I'm multiplying this here. So I'll end up with 2 to the 2x minus 3 by 2 is 6 to the 2x plus 8 equal to 0. Now you can go ahead, make a substitution and solve. Anybody confused? Right? If you look here, right, I could not have made the substitution here as yet. I had to simplify this first. If you're not seeing, I can look up there.
Yeah, but that's not blue.
That blue?
From the back, you don't see.
Yeah.
Ariel's close to 5 line.
I wouldn't write so low down again. Right, so as you all said, let y equal to 2 to the x. So remember that y squared will be 2 to the 2x. So I have y squared minus 6y plus 8 is 0. Then we solve it, right? Right, y 4 and 2 and I want minus. So I got y to be 4, y to be 2. Do I stop there? No, because y is 2 to the x. 2 to the x is 4, 2 to the x is 2. 2 to the x is 2 squared, x is 2, x is 1. Everybody okay with that? Yeah? Let's do a few more. Everything here should be add matched, right? We're still practicing them. Let's try the next one here, 2003. Online, the answers you all get, you can message them, right? Oh yeah, try them, man. Two there to try. Adam, any questions now? Got that? Yeah, but two on the board, yeah. This one and that one, 2003, 2004. Oh, yeah, answers coming in online there. Yeah, it don't matter the order, just do it. I give it time to go to them.
No, X will 37. Obviously, so bring 27 off.
That's all.
Wait, no, minus it. Right, no. Yeah. Elementary three days minus. Did you? It's 27 off them.
I have 3 questions there.
Right. Oh, wait. Very easy. Yeah, it's also a good teacher.
But you might see like more X on it. Okay, sharp. That's you.
Hey, no sé qué tal the master. Yeah, the section. And I did what else I
Why say again? Why say again?
Yeah, it's 7-1. You know, what are we going to say?
How much is it going to do? 4 or 5?
I'm fine. What's it's okay. Like, yes, I'm listening to that. I think so. I know what's that. Where? Then but we're most so we should have to tell that see me get myself on this one so I'm slow. You should not. We go on the next day. Okay.
You're done. Total. Okay. We're gonna start from the 2003 4 and then start. Go ahead.
And it's the same thing when I'm you spend some money. You got myself. You're not running this piece of extra 95. I love it. 25. Oh,
Hurry up, hurry up. How much so far?
do it.
Zero. Do it quick. Come on, do it quick. Which one you gonna do? Right now.
Yes, yes, it's Escobar. Let's go, Jordan. Check this out.
Wait, the writing bad already, boy.
Stop it.
Still power.
What's up, Cecil?
Oh, that's not.
Oi. That's serious. Jordan. We are like this shit.
Wait,
Okay, use our
black.
Black no crap.
Good time, watch your book first. And now tell you right now, that's cool.
Sorry, I'm calling Vincent. Apologies. Ready?
Alright, there you go. Nice. Right, you sure it's 9?
I want this.
Nice. Right, good. No. Right, it would be nice if you guys compare the power, then, but I could work. Hey, but only have a minute out. Keep out the zero. Yeah, you're doing good.
I can borrow a calculator. I think it's not me. Actually, let me use your calculator. Yeah, sure.
How much you all got there? How much you all got? 6 on? No, when you saw the traffic, what you got?
-1.
-1 and 3. Just put -1 and 3. Right? Alright, nice.
Come on. Yeah. Claro, que não, muito só que não matou. Que chave rank isso. Que chave ele não matou.
Alright. Well, look, the man right root 3, we are fine get that.
Oh, so it's 3, no?
It's 3 and -1, right? Right.
My bad.
Hope I didn't get up half, no? Right, next one, 2004. Who want to come there? Who want to come and try this one? Right, so this one here. Huh? See? So you have to say this is not quadratic, right?
Shift.
Put it underneath.
Oh,
Put it underneath.
like the same thing?
Same thing, but you need everything and so. Right. Wait, that's not nutrition, something.
Yes.
Right?
Something all that why. See that?
Huh? Yes, that's why it was. Recording. Right? How you get rid of fraction? What to do?
Bring it up.
So multiply everything by y. Multiply everything by y. That is limited. Somebody can solve it. Pass that. What are the values for y? Y is what? 4 and 1. 4 and 1. So, when you stop, 2 to the x is 4.
Oh, 2 to the x equals 4, so that means x equals 2.
And then 2 to the x is nice. No. Someone wrong.
Wait, this swap. Wait. What do wrong way? So who started?
No, put it needs I don't know. Right. You're okay with that? You're okay with that? But I'm interested in this one here. How are we going to evaluate it? No calculator. How are we going to evaluate that? I'm giving you 2 minutes again. Anybody have something for this one? Yeah? Go ahead. Oh yeah, try and simplify the last one. That's 2000. I lost here. Right, if you're looking for a hint, there is something that you can factorize in each one of them. See what you can factor out. Right? Convert them to the same base and see what you can factor out. Try something. Very simple.
Yeah, that makes sense.
Anything? Anybody have it? Think you have something? There's something that's factorized, right?
Alright, so you just zoom back in the real one, okay? I pass it, I just live on my feet about that. Yeah, I'm sure I want to. Like, so, I'm sure it's good. Yeah, this is still something. Let's take it out. Yeah. What do? There's no like, can you see that?
No, I guess it. Anybody online got it? Right. So what do? We can't do much, but we could convert all to the base 3. So this is 3 cubed to the 10. This is 3 squared to the 10. This is 3 cubed to the 4. This is 3 squared to the 11. So here I have 3 to the 30 plus 3 to the 20, 3 to the 12 plus 3 to the 22. There is nothing I can do in terms of adding them. I can't do anything like that. I can't square root individually because there's no rule for square root of a sum. So somehow I had to find a way to simplify this part in here. Right? What I'm seeing here is that I might be able to pull out 3 to the 10 on both sides. Right? I might be able to pull out 3 to the 10 or 3 to the 12. It's up to you, whichever one you want to do. Right? Let's just see what will happen if I factor out 3 to the 10. Right? If I factor out 3 to the 10, what will I get here? 3 to the what? 20 plus 3 to the 10. If I factor out 3 to the 10 here, what will I get? I'll get 3 to the 2 plus 3 to the 12. You okay with that? So this could probably cancel off. I don't worry about that too much. Now it becomes a little bit smaller. Huh? I can write factorize again. What it's showing is that I didn't take out big enough a value. Right? What can I factor out again here to make it simpler? 3 to the 10, and then 3 to the 2 underneath. Close it. You see what I'm trying to do, Chloe?
What you need to be the same numbers.
Okay, I write out the figure. Sorry.
So that's not it.
Right. See? Nice. So I am trying to find, so what I showed you here is that I could factor out 3 to 10, 3 to 10, 3 to 10 underneath, and I got it to cancel off here. Right? But it's still not really helping me. So there might be something else I could factorize. So somebody said, try to factor out 3 to 10 again. And I will get 3 to the what here? 10. And here I will get 3 to the, well, I'll get 1 or 3 to the 0. Yeah. What can I factor out underneath here? 3 to the 2. And I will end up with 3 to the 0 plus 3 to the 10. What happens here? Cancel. And now you'll get the square root of 3 to the 10 over 3 to the 2. 10 minus 2 is 8. And now we can see that the square root of 8 is, right? 8 to the power half, so I got 3 to the 4. Right? So the final answer is, what is it again? 81. That's okay? So the mistake I saw some people try is they try to find half of this and half of this. You want to look at how I got 3 to the 0 here? Right? 10 plus 10 is 20. 10 plus 0 is 10. Yeah. So next day we're going to focus on logs, right? And we're going to take a look at this, right? Do you all know what the graph for exponent looks like? The graph for exponent looks like this. Okay? And we are going to focus on y is e to the x. And then we're going to focus on the inverse of this called ln x. All right? So next day focusing on log and log. Okay? Ln is the same thing as log, right? Ln is just simply log to the base e. So the same rules we use here, same rules we're going to use here. Right? And then we'll do all the past papers on this. Okay? Here's where it gets a little bit tricky, right? All right. So that's it. We will stop there. Right? We will stop there for today. Next week we continue.